we need a clean copy, right,
Yeah.
of the test?
Okay, so today, no, I'll just use this one over here. Whichever one I just had. Alright, so today this is a review for your test, which will be February 1st. This is over ionic and covalent naming. Alright, so the first thing we need to do is we need to look at the periodic table. Okay, when you look in here at your periodic table, what you need to remember is you've got this stair step right here. Okay, and this is going to separate, for the most part, all of these guys over here. These are all your metals. And everybody over here, these are your nonmetals. Okay, those are your nonmetals. So when you're looking at your periodic table, remember that your metals are here, your nonmetals are there. Alright, second thing we need to talk about, ionic compound. It is a metal plus a non-metal. Okay? Your covalent. This is non-metal plus non-metal. Okay? With these ionic compounds, we're also going to see some of your polyatomic ions in there as well. So let's just look at a couple examples as far as naming. When we look at these problems here and we're asked to name these, first thing I'm going to look at is, in this case right here, these are all nonmetals. However, this is probably not a good example to start with, but this right here is one of your polyatomic ions. How do you know what your polyatomic ions are? They are on the back side of your periodic tables. So if I'm looking down here, I can see that the first one I come to is ammonium. Okay? So I have ammonium and I have chloride. So the name of this is just going to be ammonium, I spelled that wrong, chloride. On the periodic table, if you look, chlorine, it ends in INE. We need to switch this to ending to IDE. Alright, our next example here, we see that we have a metal and we have nonmetals here. This is another polyatomic ion. So the first thing I need to do is I need to write the name here. This is iron. Now, this 3 right here, remember, when we name ionic compounds, okay, if I have iron, and let's say this was iron 3+, and I have a Cl, and this is a 1-, and where did I get those numbers from? Transition metals, you're going to have to be told what the oxidation number is to crisscross it. Always in group 17, it's got 1 valence electron, and so it would look like this, right? They all have they all have 7 valence electrons. Okay, and they want to gain 1. So these are always going to have a -1, -2, -3, plus or -4. Okay, you need to write this on your periodic table every time you get this. Group 13, they're going to lose 3 electrons. Over here we have group 1. This is going to be a +1, and group 2 is a +2. So remember, these are your oxidation numbers that you need to know for whenever you have your ionic compounds. So in this case, if I had iron 3+ and I had chlorine 1-, I would take this 3, take it here, this 1 goes here, so the formula would be FeCl3. Now, that comes from iron has 1, 2, 3 valence electrons. Chlorine has 1, 2, 3, 4, 5, 6, 7. Right? It's in group 17, so it's got 7. Iron's going to give this 1 electron away. Okay? When it gives that 1 electron away, chlorine is now going to be Cl. It's going to have 8 electrons. It gained 1, so it's going to have a -1 charge. Iron is now going to have a +1 charge, and it's still got those 2 electrons. Iron needs to give away 2, so I need 2 more chlorines. Okay, so this electron is going to go here, this electron is going to go there. And so what you end up with is Fe3+. positive charge because it gave away 3 negatives. And then you have 3 Cl 1 minus. So our formula was FeCl3, and it came from those electrons being transferred or given away to the chlorine. Okay, so if I go back to the original problem, this 3, where did it come from? It came from us crossing it. So this has to be iron 3, right? Because this came from up here, and then NO3. We look over here on our periodic table on the back side of it, and we find NO3 is nitrate. So we name this nitrate. And remember, we don't change the endings of your polyatomic ions. We only use the Roman numerals if it is a transition metal, and this is a transition metal. Okay? We look at our next example. Ti is a metal, it's titanium, and we have a bromine. So, if it is a ionic compound, which is what we're seeing here, remember this 3 had to have been crossed down, right? If this 3 was, so this was a 3 plus, Br was a 1 minus, right? Because this is in group 17. Whoops, sorry, group 17. So 1 minus. So this had to be titanium 3 bromide. So look at the next example. Copper 3. Okay? We have, well, sorry. This P, there's a 3 here, right? This 3 came from the phosphorus. There's a 1 here. It came from there. So this is copper 1 phosphide. Right? And if we look, phosphorus is in group 15. It's a -3 charge. Alright. So those are a couple examples of those, of how you need to deal with those. Let me give you one more polyatomic example. If we're looking at MnSO3, this 3 right here came from here. This one came from there. So this was Mn with a 3 plus, and this is SO3 with a 2 minus. Well, Mn, if we look on our periodic table, is a transition metal, okay? And this is manganese. So this would be manganese. And this 3 tells us that it is transition metal, right? And then this is sulfite. And how did I find the sulfite? I go to find SO3 because it's more than one atom, which means it's a polyatomic ion, right? And we find it right here. Alright. If we look here, aluminum, this 3 was crossed, right? So we have Al3 plus, and we have, this is a 1 here, so this would be Cn1 minus. Now, Cn is a polyatomic ion, so we're going to look at our chart, and we find that Cn is right here. That is cyanide. Aluminum, which is not a transition metal, okay? So we don't need the Roman numerals, so for this one it's just going to be aluminum, and this is going to be cyanide. Okay? Alright, now we're going to go to the reverse, writing the formula. Alright, so if I have chromium, we find chromium on the periodic table. Okay? This is a transition metal. Sorry, this is transition metal. It tells us that it's chromium 4, so we need Cr4 plus. Phosphate ends in 8, which means it's a polyatomic ion, so we go to the back side of our periodic table. It's PO4 3 minus, so we're going to put PO4 3 minus here. Put this in parentheses, we cross these, and we get Cr3 PO4 parentheses 4. Okay? Let's look at titanium 2 nitrate. Titanium is Ti, so let's find it on our periodic table. Where's titanium? It's right here. Okay. The oxidation number is 2 plus. Nitrate or nitrite ends in ite, ITE, which means it is a polyatomic ion. So we're going to go to the back side of our periodic table. This is NO2 1 minus. We take these, we cross them, and you're going to get Ti. There's a 1 down here. NO2 2. Okay? So these should be fairly easy for you on this. Anytime it is